Water enters a house through a pipe with an inside diameter of 2 centimeters at an absolute pressure of 4 times 10 to the power of 5 Pascal. That means about 4 atmospheric pressure. A 1 centimeter diameter pipe leads to the second floor bathroom 5 meters above. That means the second floor bathroom is situated at a height of 5 meters from the ground. When the flow speed at the inlet pipe is 1.5 meters per second, find the flow speed, pressure, and volume flow rate in the bathroom. Here, this is the entry pipe. So entry pipe diameter is given to us. Entry pipe diameter is 2 centimeters. So radius is equal to 1 centimeter. And then the second floor bathroom pipe diameter is given as 1 centimeter. Therefore, radius is equal to 0.5 centimeters. Converting into meters, it will be 0.5 into 10 to the power of minus 2 meters. Next, pressure of the water at the entry pipe is 4 times 10 to the power of 5 pascals. And then flow rate at the entry pipe V1 is equal to 1.5 meters per second. And next, height of the second floor pipe from the entry pipe Y2 is equal to 5 meters. Therefore, Y1 is equal to 0. I am taking Y1 this as the reference point. From here it is 5 meters. Therefore, this is 0. Y1 is equal to 0. Y2 is equal to 5 meters. Okay. Now we know to find the volume flow rate, we have the only equation delta V by delta T is equal to AV. Am I right? So how to find this one? This we can easily find out using the equation of continuity, because the mass of the water entering into mass of the fluid entering into the pipe and the leaving the pipe is same. That means there isn't any change in the mass of the fluid entering into the pipe and leaving the pipe. Therefore, I can safely use the equation of continuity. According to equation of continuity, A1 V1 is equal to A2 V2. Okay, and where A is the area of cross section of the pipe and V is the velocity of the fluid flowing in the pipeline. So area of cross section of the pipe is equal to pi r square, and then radius already given to us. Using these things, I can find out volume, not volume, velocity of the water at the second floor. Okay, this is the velocity. Am I right? So here at the inlet pipe, the velocity will be the speed. When the flow speed at the inlet pipe is 1.5 meters per second, at the second floor bathroom, it is 6 meters per second. Okay. Next, we have to find out the pressure and then volume flow rate in the bathroom. So for that, I use the Bernoulli's equation. Okay. Using this one, I can find out the volume flow rate. Here, volume flow rate is there now. So V2 is known to me, and then A2 I can easily find out from the A2 is equal to pi R2 square. So pi R2 I know already given to me here. So pi R2 square. And then V2 is known to, just now I found out. No, V2 is equal to 6 meters per second. So using this one, volume flow rate can be found out, A2 V2. Delta V by delta T is equal to A2 V2. So using this one, so plugging in the values, we get the answer as 4.7 times 10 to the power of minus 4 cubic meters per second. Okay. Next, we have to find out the pressure. Okay. How to find out the, so first we found out the flow speed and then volume flow rate. Now we have to find out the pressure. How to find the pressure? We can find out using the Bernoulli's equation. You know, Bernoulli's equation is equal to P plus rho Gy plus half rho V square is equal to constant. Rho is the density of the fluid. Here it is the water. We know the density of the water. And then G is the acceleration due to gravity. And then Y is the height of the bathroom from the reference level. And then R the difference in the heights. And then V is the velocity. And then P is the pressure. So this can be rewritten as P1 plus rho g y1 plus half rho v1 square is equal to P2 plus rho g y2 plus half rho v2 square. And then rearranging the equation, because I have to find out the pressure at the second floor. P1 is the, let us consider y, suffix y is the at the ground, and then suffix 2 is the second floor. Okay, now it is clear, no? So second floor, the pressure at the second floor is equal to, rearranging the equation, I get this equation. Okay, now substitute the values. Pressure at the ground level is given to us as the 4 into 10 to the power of 5 pascals, and then rho is the density of the water, that is 1 into 10 to the power of 3 kilogram per cubic meter, and then G is 9.8 meters per second square, and then Y1 minus Y2. Y1 I am taking ground as the 0 at the entry level as the reference point, so that is 0. And then the second floor is 5 meters from the reference point. Okay, so Y2 is equal to 5. And then half, again, rho means density of the water, and then V1 is the velocity of the water at the inlet, and then V2 is the velocity of the water at the second floor. Now input the values in this equation. Solving, we will get 3.3 times 10 to the power of 5 pascals. That means 3.3 atmospheric pressures. Okay, atmospheric pressure is the answer for this one. Okay. Just this is a direct question based on the equation of continuity and Bernoulli's equation. Hope this helps. Thank you. Bye bye.